First question based on the single slit diffraction is the angular size of the central maxima due to a single slit diffraction is, and there are the four options which uses two parameter. One is lambda, another is a. Lambda is wavelength of light used and a is the slit width. We already discussed that for nth minima in diffraction pattern, condition to be satisfied is a sine theta equal to n lambda. Now for central maxima, if we draw the diagram for the diffraction pattern formation, this is the slit of width a, and from the central line on the screen at a point P, there is a minima. Suppose this is the minima 1, then angle is theta. So first minima, condition to be satisfied is a sine theta equal to lambda using n equal to 1. Similarly, first minima also appears on the other side at an angle of theta from the central line, and the region between these two minimas is the central maxima, and this theta is very small. So using this, we will have for first minima a sine theta is approximately equal to a into theta equal to lambda, because for a very small angle theta, sine theta is approximately equal to theta. This implies that theta is equal to lambda by a. So central maxima has angular size of 2 theta as shown in diagram, and it will be equal to 2 into lambda by a. Hence option B is the correct option. Second question is, the first minima due to a single slit diffraction is at theta equal to 30 degree for a light of wavelength 5000 angstrom. The width of the slit is. For nth minima in diffraction pattern, relation is a sine theta equal to n lambda, and for first minima we use n equal to 1. The condition will be a sine theta equal to lambda. Now substituting the value, we have to find the value of a. A is the slit width, it will be lambda by sine theta. Lambda is 5000 angstrom divided by sine 30 degree. Because options are given in centimeter, so we convert this angstrom into centimeter by multiplying 10 raised to power minus 8 divided by, and sine 30 is 1 by 2. So it will be equal to 5000 into 2 into 10 to the power minus 8 centimeter, or it is equal to 10,000 into 10 raised to the power minus 8 centimeter, or we can write it is 10 into 10 raised to the power 3 into 10 raised to the power minus 8 centimeter, or simply 10 into 10 raised to the power minus 5 centimeter. Hence option B is the correct option. Next question is, a beam of light of 600 nanometer wavelength from a distant source fall on a single slit 1 millimeter wide, and the resulting diffraction pattern is observed on a screen 2 meter away. The distance between the first dark fringe on the either side of the central bright fringe edge. The diagram for the diffraction pattern formation is having the slit with slit width A, and from the central line there is a screen at a distance capital D. This is the center C, and point P, this is the first minima on one of the side at an angle of theta. Similarly, another first minima occurs at angle of theta on the other side of the C. This is also the first minima. So angular width of central maxima is 2 theta, and the distance of the first minima from the C center is suppose y. So we can say that distance between first minima on either side equal to 2y. So we have to find this 2y. Using the condition for the diffraction pattern formation for nth minima, we know it is a sine theta equal to n lambda, and for first minima we will use n equal to 1, so a sine theta will be equal to lambda. Theta is small, very small, so we can write that sine theta is approximately equal to theta, and further we can also write it as tan theta, and tan theta will be equal to perpendicular by base, and perpendicular is y and base is the capital D. So substituting in above equation, this implies that a into sine theta is now y by d equal to lambda. So y equal to d lambda by a. Therefore, the distance pp dash, this is equal to 2y, which we have to find. It will be equal to 2 into d lambda by a. Now putting the value, numerical values, it is 2 into distance is 2 meter, and answer we require in centimeter or millimeter. So suppose first we put in meters also. So it is 2 into capital D is 2 meter into wavelength is 600 nanometer. So it is 600 into 10 to the power minus 9 meter divided by, and this A is the slit width, and slit width is given 1 millimeter. So it is 10 raised to the power minus 3 meter. So it will be equal to, this is 4 into 2 into 2, 4 into 6, 24 into 10 raised to the power 5, this is 3 and this is 2 into 10 to the power minus 9. So it is equal to 24 into 10 raised to the power minus 4 meter. If we put it into the centimeter, it will be 24 into 10 raised to the power minus 2 centimeter. So in centimeter, its value will be 0.24 centimeter, but there is no option for this. So we convert it into the millimeter. So in millimeter, it will be 2.4 millimeter. So option D is the correct option. Next problem. In a diffraction pattern due to a single slit of width A, the first minimum is observed at an angle of 30 degree when light of the wavelength 5000 angstrom is incident on the slit. The first secondary maxima observed at an angle of. We have drawn the pattern of the diffraction with single slit. In center, there is a central maxima between the first minima on the either side. For first minima, in condition we will take n equal to 1. For second minima, we will have to take the n equal to 2. And between the two minima, there will be a maxima. For example, between first and second minima, there is the first secondary maxima for which n will be taken 1.5. So using the condition for nth minima, which we write as a sine theta equal to n lambda, it is given that for first minima, for which we will take n equal to 1, so it will be slit width a into sine, and this first minima occurs at an angle of 30 degree, so it is sine 30 degree equal to n equal to 1, and wavelength is 5000 angstrom. This is the equation number 1. Now for the first secondary maxima, condition will be a into, and we have to find this angle theta, and it will be equal to 1.5 for first secondary maxima into wavelength is same, that is 5000 angstrom. This is the equation number 2. So dividing equation 2 by 1, we will have a sine theta by a sine 30 degree. This is equal to 1.5 into 5000 angstrom divided by 1 into 5000 angstrom. This get cancelled. Similarly, A get cancelled. So sine theta by sine 30 degree equal to 1.5. This implies that sine theta is equal to 1.5 into sine 30 degree, and sine 30 is half. So it will be equal to 1.5 into 1 by 2, that is equal to 15 by 20, or it is 3 by 4. So we can write theta equal to sine inverse 3 by 4. Hence option B is the correct option.